Hello everyone, this is Natasha from Nextwork here. Welcome to another live project demo. Today we are looking at part 5 of our AWS database series, and today we are going to continue on from the previous part where you set up and load a DynamoDB table for the first time. And this second part to that project is about querying the data that you've loaded into DynamoDB. That's why the project title is called Query Data with DynamoDB, and we're absolutely supercharging our DynamoDB skills today with queries. So, as a primer, you absolutely don't need to have done the very first project in order, or the very first project as in the previous project in this series, which is called, it is called, I wanted to pull it up so you can see it. It's okay. It seems like I can't pull it up right now, but there you go. It's called Load Data into DynamoDB. So this is the previous project in that series. Here you are. So this project, you don't need to have completed it in order to do today's project. You can still do today's project without this one. It's just that doing this one first helps you with understanding DynamoDB and all of its foundations. It sets up the foundations really, really well so that doing this project makes a lot more sense, and you would come with a lot of base understanding about how DynamoDB works. So I'd highly recommend checking out that previous project and coming back to this one once you've completed it. Cool. With that out of the way, let's dive into today's project by reading the 30-second summary or the brief. So, welcome to the Nextwork team. You've just joined the Nextwork team as a data engineer, and we're just thrilled to have you on board. As we build the Nextwork community, we're wanting to store our projects, videos, and community activity in a database. Do you think you can set up DynamoDB to house all our data and investigate what kind of insights we can query from our database? Now, you have already seen this intro probably from the previous project, but in this one, you're absolutely going to be analyzing this final sentence here, what kind of insights we can query from our database. So the architecture diagram actually looks exactly the same as the previous project. And the reason for that is because the services that we're going to use are exactly the same as what we've set up already. We have the data, we have Cloud Shell to communicate between us and the AWS resources, and we're saying, hey Cloud Shell, can you upload all of this data into Amazon DynamoDB and populate these tables over here? So when it comes to actually this part today where we're going to query from our database and get some insights, we're still using the exact same services to do that, and that's why the architecture diagram looks the same. But the output is going to look slightly different. Instead of just loading data into tables, we're now going to be able to query from the database and get some insights, and that insight is going to go a very, very long way. So in this project, let's get ready to upload tables and data into DynamoDB using Cloud Shell, and then we're going to query DynamoDB through the console, and then we're going to set up something called a transaction. I'm noticing that the text might be a little bit small, so I'm going to increase the font size for us right away. Sorry about that, team. If that was a little hard to read, I hope getting access to this step-by-step guide helps with taking a closer look. But in the meantime, let me just update the font size for everyone so that you can see this clearly. All right, I hope that font size is a little bit nicer and readable now. And let's get started. Now, there's always 3 modes in terms of how you can complete today's project. No touch means you don't get step-by-step instructions at all. You will just get some high-level instructions. Low touch is the midpoint, and it kind of gives you the general instructions without too much detail. But today we're going to go for high touch, which gives you the step-by-step guide with all of the details. so that it is completely beginner friendly. We always go for high touch in a step-by-step live project demo so that we can go through every single step together. We can even explain the steps, give you a lot of detail. Okay, so with that being said, please click on high touch if you're here to follow along with the detailed steps. Otherwise, go for low touch if you're thinking, or no touch if you're thinking, you know what, I want a bit of challenge today and try to do something without a lot of guidance at all. So what are we here to do today? Before we jump into step 1, please make sure that you have really read the brief and understand the purpose and the intention for today's project. It makes a big difference, it really does, when you write down this answer and you make it very clear to yourself the goals for today's project. So in today's project, we will, what are we going to do? Do you still remember? We will set up and load a DynamoDB database, and then we will query that database for insights. Nice. Okay, so make sure you're logged in with your IAM user. If you don't have an IAM user, you don't know how to log into one, check out the link in the description where we will show you how. Logging in with an IAM user is very, very easy. Once you have logged in once, you usually will be logged in again and again and again every time afterwards when you check out your AWS console. Otherwise, if you've really never created an IAM user before, please follow these steps over here to create one. Check out the link in the description as well. Okay, because once you've logged into your IAM user, it's kind of like the account admin is done, and let's dive into the real nitty-gritty project work. So this step, set up DynamoDB tables with AWS CLI, is going to sound familiar because you would have done this step in the previous project when we first loaded the data. That's why I'm going to go through these steps fairly quickly, because if you want the slower explanation, it is in the video step-by-step guide for that previous part. So in the meantime, let me open up Cloud Shell, which you can find at the very top here, and let's start running commands to set up our DynamoDB tables. Cool. So in this step, we will use AWS Cloud Shell and AWS CLI to run commands that help us create and load, create DynamoDB DynamoDB tables. All right. Cool beans. So we have just selected the icon for AWS Cloud Shell. It pops up from the bottom, and then we will go ahead to run those commands. This first block helps us create new tables, so let's set that up. Boom. So the moment you run these commands, what's happening here is you're telling Cloud Shell, you're putting into Cloud Shell, and you're giving a command using AWS CLI to say, hey, to my AWS account, I want to create 4 new tables: content catalog, forum, comment, and also post. So you've just pretty much informed your AWS account using AWS CLI that you would like to create these tables. So once you've created them, you will absolutely verify that they've been created by using this command here. So let's confirm that these tables were actually created. Let's copy this code and paste that through. Nice. And this is the wait command that we're putting through right now. Do you still remember what the wait command does if you've done the previous part? So the wait command helps us with just double checking that we have actually created this resource before moving on. If you were to run this wait command and the resource still hasn't been created yet, that command will continue just waiting. It wouldn't even finish. It wouldn't take you to the next line like this until that resource is actually done and it's actually in your account. So a very, very helpful command to run to double check that a resource exists. So we have confirmed that all 4 tables have been created. Why? Because all 4 commands were successfully finished. It's already finished running, so the waiting's over. the resource exists. We've created 4 DynamoDB tables just like that. And to double check, we can also use that visual AWS console by clicking into DynamoDB. You can search for DynamoDB on the search bar, clicking into that, and poof, off we go. Look at that. 4 tables created right in front of us. How satisfying, isn't it? It was so fast. So if you're wanting a quick recap on what is DynamoDB and what are DynamoDB tables, what we've created just now is a table, and a table is used to organize data, like most databases. But the special thing with DynamoDB is that 1, it's a non-relational database, and 2, it is also a database that organizes data using key value pairs. So the reason why DynamoDB is unique for that is because there are lots of different types of non-relational databases, but DynamoDB is one of the only ones that uses the key value kind of mechanism or key value technique to store data. And what you can see here is data is kind of sorted into tables, and then each table is pretty much separate from each other. So here are some example data that we can store in DynamoDB, and you can see how one of them is just storing comments that have been left in the Nextwork community. Here is a content catalog, which is another table that stores all of the information about social media content or projects that Nextwork writes. Here's another table that's called forum, and forum are pretty much like channels inside the Nextwork community. Last is post. Again, something related to the Nextwork community. Post could be a database that just stores all of the posts that students write inside a forum. So you can see how this data can be related, but then they can be stored in completely separate tables. You have the Nextwork community, and the Nextwork community is split into different forums. And then in the forum, people can write a post. I can make a post inside a forum. And then after I make the post, someone else can leave a comment on it. All right, and all of that data can get stored in separate tables. Content catalog will be something that doesn't really relate to comment, forum, and post as much, but it is equally important. Content catalog can be storing some very important data. Okay. Now, I know what we were doing just now was moving a little bit fast, so if you're completely new to what we've been doing, just know that those slower in-depth explanations are available in the previous project video. Cool, so we can see that we have the 4 new tables, and now we're ready to load the data. So now we're ready to go from a folder somewhere, that exists in the cloud, and getting all of that folder's data to go into Amazon DynamoDB and then load it into all of our tables. So let's start with that. In this step, we are using AWS Cloud Shell and CLI to load data into our DynamoDB tables. Again, this step is also another step that was covered in the previous project, so we're going to go a little bit fast. We're going to head back into the Cloud Shell terminal, and we're going to download and unzip this folder that's filled with data for us. So let us paste that in here. Aha! And this is a special error that you're going to get, or not error actually, but this is a special, is it an error? Maybe it is. It's a special kind of response from the terminal if you have done the previous project. So if you haven't done the previous project at all and you're coming in fresh, you're not going to see this. You're going to see a different kind of output that doesn't include any mentions of error. But in our case, we're seeing something that's called error, invalid response, etc., etc., etc. And the reason for this is because if you've done the previous project, you would remember that Cloud Shell is also a storage space for files. And because we have already unzipped this file before into our Cloud Shell environment, Cloud Shell is still storing that file for you. So if you were to run these commands again, CloudShare will be like, hey, you've downloaded this folder before, you've unzipped this file before. Now you have another folder with the exact same name as an existing one, and the folder has files, all with names that are exactly the same as existing file names. So are you wanting to replace all of the existing files with the new files that you're just downloading now? Do you want to do that? And it's asking you to type in a response to that, like, do you want to do it, yes or no? Honestly, whether you say yes or whether you say no, it's not going to make a big difference because the file looks exactly the same. So if you were to say yes, you're technically replacing your existing saved files with the new ones. If you say no, then the old ones stay, but then the files themselves, the content is exactly the same. So yes or no, all doesn't matter too much, but let's just click yes for in our case, and you're gonna see, oh my goodness, we have to say yes many times. That's right, yeah, we have to say many times because we have to say yes individually to every single file in that zip file as well, because we unzipped the zip file when we ran this. So all of the duplicated files inside this zip file, we have to say yes to independently. So let us just click yes. Take your time. We're not in a rush. I hope you're not in a rush. And then once you're done writing yes, you're going to see that the last line doesn't ask you to type any more yeses or nos. It's now ready for you to run the next command. So we're going to run ls, and that helps us confirm, ls, I wrote ks, ls, cool. And that confirms that we have a folder called next example data, which is what we want. And then these other two files we can ignore. These are kind of just additional files that come with downloading that zip file. But really what we want is just the folder that's inside, right? So let us navigate into the folder inside by going into network sample data, running cd network sample data. Okay, and let's run ls again. Once you run ls, look at that. You have a file called common.json, a file called contentcatalog.json, a file called forum.json, a file called post.json. So that's perfect. This is exactly what we need. You can, these extra little files would likely pop into your account if you've tried to delete some files using CLI commands from the last project, but no worries. It's okay to keep them here. It's not going to cause an error. We'll just leave them here, and then we can delete everything at the end if we want. All right. Your challenge now is to understand what's inside these files, all right? We've downloaded a folder, a zip folder. That zip folder contains files. What's inside those files? You can find out by running a command called cat. So let's type in cat, C-A-T, and then forum.json, enter. Look at what you see. Whoa, look at that. You get to see the contents of forum.json right in the terminal. It's so handy. You don't even need to have like a document viewer or anything like that. Just run cat and you can see the contents of your file. Super handy, and running cat shows us that forum.json is formatted really well. Forum.json shows us that the forum.json is showing us data that we're going to need to load into our DynamoDB tables, right? So here we can break down forum.json by looking at the different components. So that first line, forum, is basically saying the data that's in this file needs to go inside the forum table. All right, and we have a forum table in DynamoDB. We have a forum table, right? So we're about to upload some data. So the file, the data inside forum.json is for the forum table. And it says, put request, please add this item. This item contains these attributes and these attribute values. Again, put request, please add these values. Please add this item. Okay, and this item has the following attributes. So really forum.json is just asking DynamoDB to do two things. Can you please add this item? And then once you're done, can you please add this item into forum.json? is absolutely very, very similar for all of the other files in the folder. So if you were to run cat common.json, cat content catalog.json, you're going to see very, very similar looking things. So now that you know what's inside your JSON file, you can just load that data into your DynamoDB tables. So this command called DynamoDB batch write item is going to be very helpful for us to just load all of that data all at once instead of having to wait one by one. Awesome. So off it goes, Cloud Shell and CLI working together, putting our commands through. AWS has now uploaded all of this data for us. And there are no unprocessed items as well. You see how this is an empty list called unprocessed items? It means unprocessed items is like a list of all of the data that couldn't get uploaded, because of any reason, like errors, for example. But for us, it's a blank list. That means all the data uploaded successfully for all of the files. Very good. We love a win. We love a good win. So with that done, you can head back to your DynamoDB table, okay? And then you can refresh it like this. You can even pick the content catalog table, yeah? And then select this button called Explore Table Items to take you to a page where you can read what are the contents of this table. Yeah, so we have 6 items for this one. And since we were familiar with forum, let us click into forum. And you can see there are 2 items, right? Just like how there were 2 items in here. We had 2 items. One was called I have a question. The other one was called events. And if you were to look here, perfect. We have 2 items. One's called I have a question. One's called events. All right, so we were looking at the content catalog table, so let's head back there. And with the content catalog table, you're going to see all the data or all the attributes that this table can hold. Now we're going to go into just a little bit of revision from the previous project. I'm going to ask you this question. Okay, do all of the items have the same number of attributes? I mean, we do have columns going up at the top here. So does that mean 201 has an author attribute, has a difficulty attribute, has a project category attribute, has a publish attribute? Does it have that? So you can double check your answer to that by doing a bit of discovering. And here we're going to do a bit of clicking around. But before we do that, I think I'll let you guys have a think about the answer. Do all the items share the same number of attributes? Alrighty, so now that we've had a think, let us explore. We're going to start by clicking into an item with an ID of 1. So you can honestly click into either one of these 3, 1, 2, or 3, but for this demo, let's go with 1. So let's click into 1, and ta-da! You can see that there are all of the attributes for this specific item laid out here for you. You can see that there's an attribute called content type, difficulty, price, project category, published, title, URL. What a list of attributes for a single item. So we're storing a lot of data about this item. Let us see now the attributes for a video. So you can see how this one is called a project, and now we're going to see the attributes for a video. Let's click on that. A shorter list of attributes. Interesting. Now the attributes for video includes the ID, content type, price, services, title, URL, video type. So you might notice that actually some attributes are the same, but it's not the same number of attributes, and they can also be different attributes. That is a very, very important thing to know about DynamoDB tables, because it tells you a lot about how data is organized. If we were in a relational database, every single item will need to have the same number of attributes, right? Because we're storing things in rows and columns, so there's going to be an intersection between every row and every column, and every intersection will need to have a value. Even if it's null or none, that's still considered a value, right? Because you're typing like null, you're typing none, and that still can hold a bit of storage space. But in the case of DynamoDB, it's almost like that cell doesn't even exist at all. So it's not like the attribute for 203, it's not like here for 203, it's going to have like a null value for authors. It's just that this attribute just doesn't exist at all. And when you have that kind of flexibility in a database, you end up saving a lot of space and things end up a lot faster when you're querying for data. So that is like a handy little tip when it comes to DynamoDB tables. Cool. Now that was a lot of the steps that we ran in the previous project in the series. So now that we have almost like finished repeating those steps, the remainder of this project is completely fresh. So now we're about to do a lot of new things together, starting with running a query. We've talked about queries earlier in this series. Querying is pretty much like sorting, filtering, like picking specific parts of your data to gain some insights. And in this case, we can absolutely query our DynamoDB table to get insights. So that's what we're doing in this step. In this step, we are querying our DynamoDB tables for insights. Okay, let's run our very first query. Are you excited? To do our very first query, we're going to stay on the content catalog table here. But this time, we're going to scroll back up. And there's this heading here called Scan or Query Items. We're going to expand that. And we're going to select Query. Aha! So we're no longer just scanning. Scanning is like just reading or seeing everything that's in that table. Querying is like, I don't want to see everything. I just want to see the specific thing. So we're going to click on Query now, and then we're going to enter an ID or a partition key to query for a specific item. Let us enter 201. Can you remember whether 201 is in our table? Here you go. Here's the answer. Yes, it is. So in this case, we're going to type in 201, and then we're going to select Run. Aha! Now only 201 is appearing under items returned, and that is because 201 is the only item that has the ID 201. And that's why when we type in ID as our partition key, only one item is returned. Here's my challenge for you. Can we create another item with the same ID 201? Would that be possible? This isn't even a part of the project step-by-step guide, but this can actually be a quite good extension to do. Let us click on Create Item. Just quickly type in 201. Can we create this item? 201 already exists in the table. Can we? Let us click Create Item. Aha, interesting. The conditional request failed. An item with the primary key you provided already exists. So in this case, we can't actually, because an item with the primary key, which is the partition key in our case, already exists. So you might be a little confused. You might be wondering, hold on a second. But here we say partition key values don't have to be unique. For example, if color is a partition key, items can share partition key values like blue, green, red, and more. Then why is it that just now we ran into an error that said we couldn't create 201 like this? And something about the primary key, why did we have this error? So the reason for this is because the primary key is not exactly the same as the partition key. The primary key is kind of like the unique ID that every single item needs to have. And when your table only has the partition key as a way for your DynamoDB to partition data and find data, then the partition key is pretty much the same thing as the primary key. Now the partition key becomes the primary key because it's the only way that DynamoDB can sort and filter data. So what is another scenario where the partition key isn't the primary key, that we can actually have repeated partition key values? Let us find out now. So let us find out now by checking out another table. We're now going to check out the comments table. Click on comment and look at this, okay? Do you see that we now have items with the exact same ID? How is this possible? Previously, we just got the error that said, oh, we can't create an item with the exact same ID because that primary key already exists. But here we are seeing proof that now we have items with the exact same ID, and they can obviously both be in the same table. How could that be true? So let us answer that very interesting question by clicking on that scanner query items toggle at the top again. Select query now, and notice that we have the ID, the partition key, but there's also something else at the bottom. Ooh, this one is called a sort key. So what is a sort key? And this is also the answer to that question previously. A sort key is a secondary key that you use to filter your query results again. It's like a second filter. Sort keys work after the partition key, i.e., you still have to use the partition key first. Like, this is still an absolute must. Every single item still needs to have a partition key. But then, if you want to split up items that have the same partition key, you would use the sort key, like that. And then, sort keys are optional, which is why the content catalog table could still work without one, right? When we clicked on content catalog, there was no sort key at all. Sort keys didn't exist with this table. But of course, sort keys do exist here. And whether or not your table has a sort key is something you can definitely set up when you create a new table. You would just click on the option to enable sort key, and then you would put in the sort key name, all of that good stuff. Now, because this comment table has a sort key, the primary key, which is that unique ID I was talking about, becomes the combination of these two. This plus this must be unique for that item to be created. Previously, content catalog only had partition key, which meant the primary key, that unique ID, had to be the partition key alone. That had to be the very unique number that every item has. Whereas for comment, because comment has two different keys, the partition key and the sort key, it's only the combination of these two that needs to be unique. Okay, so two items can absolutely share the same ID. Two items can absolutely have the same ID as long as their sort key is different. So you can see you have two items with the exact same ID here. Okay, they have the exact same name, but is their common date time, which is the sort key, is this different? It is. The first one is 2024. 2024 9/15. 9-15, which is the date, and then the one below, 2024-9-22. All right, same with these two. They share the exact same name, the exact same ID, but why can't they be in the same table? Well, because their sort key is different. All right, so that is a nice little tidbit for you, a nice little extra if you're watching this live demo on this extra thing about partition key and sort keys and how they work to give our items the primary key, that unique ID. If you want to see this in action again, let us do this on purpose by creating an item. This is a little idea for you to understand what we were talking about. Let's say we were just creating a new item. They have the exact same partition key as the other items. But for common date time, let's say it's something completely different. It's 2027, and then it is the 1st of September in 2027. Once we create it, we can still make it. How good. Now, what if we were to give this the exact same common date time as another item? Can we do that? let us try updating this sort key and make it the exact same value as another item. If we were to recreate it, aha, now is when we get the same error. The primary key already exists, right? Because that unique combination of this ID plus that sort key already exists. Okay, cool. So that was just a nice little tidbit for you, but let me delete the item so everyone is seeing the exact same thing. All right, so here we are. So now that we know what sort keys are and we know what partition keys are, I think we are ready for the first question. Oh, what do you think this table is displaying? Oh, okay, very cool. Slightly different to what I was just talking about, actually. So we might come back and look at this table again. What you're gonna write for this question is not gonna end up in your final documentation, so just don't be afraid to make any mistakes. Just give it your true, genuine best guess. You know, what is displayed in this table? Okay, what's going on here? What's going to really help is to just expand all of these, yeah, to better understand what is being recorded here. Oh, oh, every time I try to expand it, it snaps back. All right, here we go. So we can see here that in this table we have a bunch of IDs. Okay, we have a bunch of common date time, a bunch of messages, and a bunch of posted by. Okay, so here in this table, in this comment table, each item is an individual comment that's been left in a next work post. Each item has the same attributes for now, i.e. they all have an ID, a common date time, they all have a message and a posted by attribute. So this table is storing 4 comments so far, and those comments were, you know, they were left, they were each item is a comment. For example, someone called Abdul Rahman in the community has left a comment that says, "Great work." Abdul Rahman left that comment on the 15th of September 2024 at this specific time. And then that comment was left on this specific post called location of documentation, IAM user setup for the projects. And then that post lives in this forum that's called I have a question. So that's how IDs are made. This ID is created by a combination of the forum slash the post name. So here we have a comment that's been left in a post called Just Complete Project 7 Dependencies and Code Artifacts. And that post lives in the forum that's called I have a question. All right, so that comment was a single word comment that says excellent. It was left again by Abdul Rahman, and then it was left at this specific time. So that's exactly what this table shows us. It's just a database table about all the comments that have been left in posts in the community. Okay, cool. So now we're going to try to query this because we haven't actually run a query yet. We're going to use the query in terms of how we can query this. We can use both the partition key and the sort key now. So let us just enter a single ID as our partition key. Let's just paste that in here. And when that's done, let's click run. Oh, that's right. Only 2 items were returned. Okay, because only these 2 items have this specific ID. Okay, the other 2 items didn't have this as their ID, so they're not here. Shall we amp things up by also adding in the comment date time, the sort key, as a filter? Yeah, let's do that. So another way that we can further filter this down is to use the comment date time. So notice how for comment date time, they're a little bit different because the dates are different. One is 2024, 9 and then 15. The other one is 2024, 9 and 22. So how we can really see the power of this is by making comment date time equal to less than, greater than, between, begins with. We can say we only want it to be greater than 2024, 09. What's a date in between these two? Shall I just say the 20th? Let's say 2024, 09, 20th. Run that. Now only one item remains because only this item was left after the 20th of September in 2024. So you successfully queried it a second time. That's pretty cool. We're going to take a screenshot of that scan or query item section. Cool. And let's drag that screenshot in here. Looks good. And then let us answer the question. What is a partition key? A partition key is, do you remember? A partition key is the main tag, or ID that DynamoDB will use to partition its table's values, items. The partition key, let's be clear that every item must have a partition key. Yeah, and that the partition key's value can be and the partition key's value must be unique unless, what do we want to say? The partition key values can be unique, must be unique, unless a table also has a sort key. Done. This lends us quite well to the next question. What is a sort key? So a sort key is a second filter or tag that DynamoDB can use to search for specific items. If a table, and let's make it very clear that sort keys are optional. If a table has a sort key, then each item's primary key is made of its partition key plus sort key. Nice. This means partition keys can be the same if sort keys are, I ran out of characters. No. Let us try to make this a bit more concise so I can have characters to fill. So I have characters to use to write. A sort key is an optional second filter or tag. Second filter the DynamoDB can use to search for specific items. If a table has a sort key, then each item's primary key is made of its partition key plus sort key. i.e., partition key values can be the same if sort keys are not the same. What I would really say is partition key values can be the same if sort keys are unique. That would be an even better word. If you're better than me, then at making this concise, please beat me to it. Write a better paragraph and tag me when you post your documentation. All right, let's click done. Okay, cool. Here's your next challenge. How would you look for all comments that were posted by user Abdurrahman? So we know exactly what our table looks like in all of its items with ID, comment date time, message, posted by. Can you tell how to just find all of the comments left by the same user? Posted by isn't the partition key or the sort key, so how will we do it? Let us try query this anyway. And, well, can we use a partition key? Not really, because user Abdurrahman's comments are left across many, many different posts, and each post means a different partition key. So we can't really just look for a partition key value. What if we did filters? In filters, you can start to have very, very customized tags of literally filters that you can use to narrow down your search again. So we have an attribute name, don't we? The attribute name that we're trying to use to group our results is who it's posted by. We only want these two results. So posted by needs to be, posted by is it the type of posted by is a string, it's a piece of text, yes. And posted by needs to equal to user Abdurrahman. All right, so technically there's no specific ID that we would narrow down to. There's no specific sort key that we would use because it's all spread out. The only thing that really ties the desired results is that they were all posted by the same person, user Abdurrahman. So let us click run and see what comes up. Turns out, do you see this? Oh no. Turns out the partition key filter cannot be empty. So that teaches us two things. All right. If we were to enter a partition key value, our hands would be tied in terms of what kind of results we can get, right? Because if I were to put this through, I would technically get one comment by user Abdurrahman, but not both of them, not all of them. So we've just learned that this is a bit of a restriction when it comes to using DynamoDB. Whatever attribute that you decide will be the partition key will have such a big difference in terms of what kind of queries you can make and what kind of search results you can get. And that's the reason why data modeling is so important. Data engineers think very, very deeply about these kinds of problems. So what that means is, before you ever create the table, before you even upload the data engineers spend so much time carefully preparing the exact structure of that table so that they can prepare for and design for what kind of queries that they would run after that data has been uploaded. In our case, let's say we've set up this table, not realizing that some of its users might want to query based on all of the comments made by user Abdurrahman. If that's the case, it means, maybe this comment table needs a bit of changing up, just so that when we query, we'd be able to query based on the things that we want to group by. So I hope that was helpful, and that data modeling is something that makes sense. Data modeling, like I mentioned, is all about the whole planning phase of how to set up your tables. So what should the table's partition keys and sort keys be? These are the kind of questions you would ask when it comes to data modeling. Let's take a screenshot of the error in the scan or query items panel. Now you can see I don't have that error right now because user Abdurrahman and everything I added it just now when I wanted to demo having only one item returned. But once you clear that field, you'll easily see that error again. Let us take a screenshot now. And this shows us the error that happens when the partition key filter is not empty. Let us upload that. Next, why did your query result in an error? I ran into an error when I queried for, why was it? This was because, so let's do that. I ran into an error when I queried for all comments made by a specific user. Actually, what really happened was we ran into an error together. So let's just make this about we. This was because queries must use the table's partition key. And the posted by attribute was not the partition key. Which I use to filter results. All right, so let me read that out so we can review this response together. Why did that query just now result in an error? We ran into an error when we queried for all comments made by a specific user. This was because queries must use the table's partition key and the posted by attribute, which we use to filter those results, which we use to query our data, was not the partition key, didn't use it at all. Share your learnings back with the NextWork team. Don't forget you're NextWork's first data engineer, and we want to know what are insights we could extract from the comment table. What are insights that would be a little harder to extract from the comment table? So you're going to now say, as a data engineer, hey guys, I've done a bit of research into our data. Insights we could extract from our comment table includes, all comments left on a single post. Insights we can't easily extract from the comment table includes all comments made by a specific user. Cool. Oh, actually, since we have a few characters left, let's might as well improve this answer a little bit by adding an extra detail. Insights we could extract from our comment table includes all comments left on a single post and even sorted, filtered by comment date or time. Yeah, and then insights we can't easily extract from the table includes all comments made by this specific user. All done. So now we're ready to run queries with AWS CLI. Now what this means is we're going to use Cloud Shell as kind of like the environment where we're going to use CLI. And then we're going to say, hey, DynamoDB, can you get this specific item for us? And now DynamoDB says, understood. It actually understands this command. It's going to say, understood. I'll get you that item in this content catalog table that also has an ID of 201. Okay, cool. Thanks. All right. So in this step, we are using, what are we doing? In this step, we are using AWS CLI to run commands that query our data. Cool. Alrighty, when we're ready, let us head back to the AWS Cloud Shell environment. Handy stuff. And this time we're going to run a CLI command. Alright, the CLI command says get item. and gives us a specific name. It gives us even the partition key. So let us copy that and run that here. Oh, look at that. So just like that, we ran this command that says, give me this item that's in the table called content catalog, and it should have a partition key of 201. You run that using AWS CLI, using Cloud Shell, and here's your response. Oh yeah, here's the item. It has a title of da 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 da. It has a price of $0. It's a video, it's an educational one, and then the content type is, what is it? The content type is, oh, we can't see. So it turns out when you have this kind of output where it's like a colon and then a rectangle, you can press down key, the down arrow on your keyboard, to see the rest of the results. So in this case, we've now just also exposed that the content type is a video, the services that it's included, Amazon RDS, DynamoDB, all of these other attributes about the same piece of data. All right, so you can press colon and press Q to leave this window. Here you go. And just like that, you have run your very, very first query using AWS CLI. Impressive. Cool. Looks like I've jumped the gun a little bit. No, not at all. I haven't jumped the gun. Because we are still running a new command. Run this command. All right. So before you even read the explanation for this query, what do you think it'll return? Okay. And what you write here for this question is not going to be marked. It's not going to end up on your documentation. So make mistakes. It's all about reading this question and getting your creative juices flowing before you read an explanation. Have a think. What do you think this is going to return? Alrighty, so content catalog is the table name. Alright, so we're still staying in the content catalog table. This one has a key of 101. Oh, it's a different key. There's something called consistent read. Okay, interesting. And there's something called projection expression. Very funny, cool, cool line, cool item, cool command. And then we even have return consume capacity total. So we have 3 new lines to unpack here, but at least we're familiar with those first 3. So anyway, let's copy the code and let us run that and see what comes out. All right, so what that just showed us is consume capacity units 1.0. Now we've learned capacity units in the previous project. It's pretty much like asking how many engine does it require to run this command, or how many engine does it require to run this operation. Okay, and we were just running a read operation because we were just trying to get an item. We're not trying to write into the table. And then what this output tells us is, oh yeah, that read operation requires 1 capacity unit or 1 read capacity unit. So that's like needing 1 reading engine to power. So before you read the explanation for everything else, what do you think it'll return? We think this will return another item in the content catalog table. All right. And now let's really dive into what these extra 3 lines are saying. So what does that first line say? That first line, called consistent read, is something that you would write if you want a strongly consistent read. Okay, and what a strongly consistent read means? It means DynamoDB will give you the guaranteed most recent version of that item. By default, a read from DynamoDB doesn't use a strongly consistent read. It actually uses something else called eventual consistency, which is a very much a lower cost option, but it also is faster, and it retrieves a version of the data that might not be the most updated version, but it would be really, really close. Usually, eventual consistency becomes the most updated version within like a second of you updating the data. But in situations where that extra second matters, you just want that absolutely the most recent updated version of that data instantly. You can't even wait a second. You would use consistent read so that you're going to get the most updated version of that data, which is called the strongly consistent read. Okay, we even have projection expression as another line, and projection expression means you only want to see some of the item's attributes. I only want to see the item's title, the content type, and the services. Now finally, return consume capacity tells us is a way for you to request that you want to know how much capacity was consumed by the request. Does this sound familiar? Does this sound familiar at all? Well, return consume capacity total, this is the output, right? It's definitely done its job. Return consume capacity has shown us how much capacity was consumed by the request, 1.0. So what this means is we've successfully received the output of return consume capacity is right here. But where is the result of our actual query where we're trying to get an item? All right, the previous time we ran get item, we definitely got an item back. Look at that, all of its details are right here. But now now we run get item one more time, we don't even get the item itself. It's just the consumed capacity. Why is that? Well, check again. The ID that we're looking for is 101. Is there an item in the database table with the ID 101? Have a check. Have a check at comment catalog and look at what you see. Okay, you might need to reset so that you're back to the scan with all 6 items. Is there an item with an ID 101? No, there isn't. That item doesn't exist, which is why when we ran that command in Cloud Shell, where we requested an item with ID 101, no item was returned to us. Okay, so let's take a screenshot of that query and the response in Cloud Shell. Nice. And let us upload that. Very nice. A query I ran in Cloud Shell was, this query will. All right. What was the last query you ran? A query I ran in Cloud Shell was AWS DynamoDB -get item. This query will. This query will. This query will grab the item from the table and with the partition key value that I described in the command. Oh, and since we're all doing this together, let us go from I to we again. A query we ran in Cloud Shell was AWS CLI get item. This query will grab an item that's from the table and with the partition key value that we described in the command. Cool. Explain what the 3 query options do. Query options I could add to my query are, can you remember? Well, I mean, they are right here, so we can refer to these. All right, so they are consistent read, which provides a strongly consistent read. All right, there's also projection expression, i.e. only return certain attributes. And the last one is return consumed capacity, which returns the number of capacity units consumed. All right, let's push done for that. All right, and we're now ready to set up a transaction. Are you ready? So, for our grand finale when it comes to querying and really analyzing our data, this last step is actually to really recognize that our table contains a lot of related data. Each forum can contain multiple posts that's inside, and each post can contain multiple comments. Have a think about that for a second. You might want to even click on the tables that's provided here to really see the relationship going on here. You know, each forum comes with its own comments and posts. And as you can see here in comment, that comment ID is absolutely related to which forum it's in and then which post it's under as well. So you can absolutely see that there can be related data, you know, across your DynamoDB tables. So how do you keep the information consistent across all of them? A great technique that you could use is called a transaction. So in this step, we're actually not going to be querying the data as much. Rather, we're going to learn this technique called transaction because it really helps us with understanding how to handle the related data across our DynamoDB tables. Okay? So in this step, we are stepping away from querying to practice a transaction, which is a technique that helps us manage related data. Related data that's across DynamoDB tables. Okay, so let us see. Okay, cool. So I think this intro is very clear now. You're going to just update two tables in a single command to carry out that transaction, that technique. Cool. As we mentioned before, when you check out forum, you're going to notice that there's a count for the number of comments, i.e. all the comments that were left inside the forum. Yeah, so as you can see, there's an events item, there's an events forum, and events forum has 0 comments. It's quite quiet right now. And then we have I have a question forum, and this forum contains 4 comments. 4 comments were left there in total. So we can even cross-check this, right, by checking out the comment table and noticing that if you were to look at, if you were to click reset and click run so you can see all the results, all 4 comments in the comment table belong to the I have a question forum. Yeah, so this is the reason why when you click into forum, all 4 comments are next to I have a question. Okay, and there are no comments next to events. But this starts to really show you the importance of understanding related data. Because if someone were to comment on something in a post in events, not only do you need to add that comment into your database table, you also need to make sure that something that's recording related data, in this case, this forum, is still containing the number of comments. This needs to be updated and reflected accurately. Okay, so we're going to take a screenshot of the forum table to kick us off. Just like that. All right, upload that screenshot. And next, we're going to answer this question. How are tables in DynamoDB related? Apologies for that. Apologies for that typo. How are tables in your DynamoDB database related? Start your answer with, my DynamoDB tables are related to each other because there is an attribute in the forum table called comments, and that attribute must accurately reflect the actual the number of items in the comments table with an ID referencing that forum. Cool. So that is our challenge, right? So how would you actually make sure that when a student posts a new comment, the number of comments recorded in a forum also updates? See, that is really our challenge here today. So let's try to do this by using AWS CLI. Run this in your AWS Cloud Shell environment. All right, so let us, I know it looks pretty intense, it looks a little big, so we're gonna run it first and then we're gonna really talk through it. Okay, so in this command, we're saying, hey AWS, can we visit the DynamoDB service? And I want to write items in a transaction. Our keyword today, transaction. Okay, and this transaction should affect two tables. Okay, the first, and it's also going to involve two actions. The first action is called put, which is basically to add to a table. We're going to add to the table comment. All right, we're going to add to the table comment the name of this is the name of the forum. It's called events. This is the name of the post in that forum that is related to. And then there's also the comment itself, excited to attend. And it was posted by Dear Connor, user Connor. And then after you add that item, can you please update the events item in the forum table, because the number of comments needs to go up by 1 because someone left a new comment. Okay, so with that done, in a transaction, you're really just recording a new comment, but you're updating two tables so that they're accurately still up to date with each other. Yeah, so let's take a screenshot of that transaction command. All right, let's upload that screenshot. Oh, done. Let's click done. Oof, off it goes. And we've updated both the comment and forum tables. Let us go check our work. We can run this command in Cloud Shell now to view the events forum, and you'll see that the comments count should really go up from 0 to 1. Let's find out. Woohoo! Look at that. Do you see how under the events, under our table forum, we specifically made a query for an event, for the events forum. And look at that. It's now showing us all the attributes related to the events forum. There's one post in there, there's one comment left in there, and some other attributes related to events. But really, what's important here is we really went from 0 to 1. Yeah, before there was no comments attribute at all. But now there is a comments attribute and the value is 1. Perfect. we've left our very first comment in the events forum. All right, so with that done, let us respond to the question, what is a transaction? A transaction is a group of operations that are bundled together and get executed as one. Something important to note about a transaction that I realize I haven't really mentioned before is something important about a transaction is when you're looking at it. Let's have a look at it together. The transaction will only be successful if both commands run successfully. So let's say we successfully added a comment item to the comment table. But let's say for some reason we made some sort of typo or some formatting issue with the second half and the update could not happen. If that's the case, this action gets cancelled, it gets reversed, because the transaction would only be successful if both parts or all parts of that transaction was successful. That's a very, very important tip about a transaction. So let's add that into our definition too. For the transaction to succeed, all operations within that transaction must process successfully. All right, done. How did you just run a transaction? Yeah, we did a transaction, didn't we? I ran a transaction using, what do we do? And what transaction, what actions did it do? We ran a transaction using AWS CLI commands run on AWS Cloud Shell. This transaction did two things for us. That's right. This transaction, first, what did it do? Can you see? What did it do? First, it added a new item to a table. Then, the transaction updated an item in the forum table. Events comment count increased by 1. Awesome. Let us click done to send that answer through. And nice work! You've just learned how to create a DynamoDB table. You've also created some fantastic queries. I would add to that list and say you've even processed a transaction. That was cool. Thanks for sharing all of those juicy insights. You're off to a rocking start as Nextworks data engineer. And if you wanted to confirm your work, you can even refresh this table to see that comments is now 1. Yeah, which is exactly one of the things that our transaction did. Very nice. So with that wrapped up, we can now delete our resources and finish up this project. Please make sure you delete all your resources because AWS can start charging if you leave your resources running. In our case, we only have one really important resource to delete. I feel like I just scrolled and showed you the answer, but if you haven't seen it yet, can you guess what it is? Drum roll, please. So the item or the resource that we want to delete is our DynamoDB tables, all of these tables here. You can absolutely delete a DynamoDB table using the console, okay? And we're quite familiar with the console now probably, but what we're not too familiar with yet is CLI. So we're gonna choose the hard path today and use the CLI to delete the tables. Now again, just now I realized I didn't explain what I was doing just then, but if you see that rectangular kind of cursor and it doesn't let you type in new commands like this, just again go colon and go Q for quit. Okay, it just basically quits this little mode that it was on where it was on viewing mode, so you can press up and down to view all of the results. Oh, All right, cool. Sorry about that little mistake there. I think I accidentally refreshed something. I wonder what was going on there. All right then. So now that we're back in our Cloud Shell environment, let us delete our DynamoDB tables by copying this excerpt of 4 commands and then processing that through our terminal. All right, do you see how sometimes you might need to press enter? Like in this case, our cursor is still stuck on the second command and we need to press enter to let it go through. Oops. Let me press Q. Again, do you see how we are in that funky little cursor where we can just see maybe end or maybe we were in the middle of something. Just press Q to quit. All right. And it looks like comment was deleted. Shall we go check our tables to see whether that worked? Yeah? Let us go into our tables inside DynamoDB, refresh. Aha, comment was successfully deleted as a table. So let's try do that for the rest of our tables. Let us now try to delete forum. Okay, very cool. Again, when you see that that little rectangular thing, you can press Q to quit. And let us try do that again for the other last 2 remaining tables. Oh my gosh, we're so close to the end of the project already. Wow. And then let us again run that for the final table called post. Okay, press Q again. Done. All right, so you can again refresh that tables page, and we have no more tables left in this AWS region. Alrighty, so that tells us that we've successfully deleted all the resources involved in this project, so we can wrap up with a quick reflection and finish off for the day. Another AWS service done. What is Amazon DynamoDB and why is it useful? Amazon DynamoDB is a non-relational database service. Is a non-relational AWS database service. DynamoDB organizes data into tables where data is stored. Actually, let's say DynamoDB stores data in tables where data is organized using items and attributes. How did you use Amazon DynamoDB in today's project? In today's project, we use DynamoDB to, what do? To create and load tables. What else did we do? Can you remember? So we've created and loaded tables. We also, we ran queries over the AWS CLI. Yeah. And the console. We also process transactions, i.e. ran multiple operations at once, as one, to manage related data. I honestly love transactions so much because imagine if you had to update the tables separately. I feel like that opens up all of these potential errors, especially if you're using the console to edit your data separately. So a big shout out to transactions for that one. What is one thing you didn't expect in this project? One thing we didn't expect in this project is that DynamoDB queries have to use the partition key in scenarios where we want to group results or find data using only other attributes, we run into an error. And how much time did this project take today? I'm going to estimate that took about an hour, maybe an hour and a half. This project took us an hour and a half. Not too sure. I've lost track of time today. I didn't check when I started. Oops. This project took us an hour and a half, including demo and explanation time. All done. Woo, that was very satisfying. So now that we have answered all the questions for today's project, you can share your work. So what will happen is at the very end of your project is a mission accomplished button. Click on that. Woohoo! And now you have access to a previewed LinkedIn post that's going to show you what you can do to how you can write a LinkedIn post to share your work. And of course, you can also view your documentation so that you can also see all of your answers and your PDFs or screenshots in a single PDF. Let me show you what that looks like. Like this. Oh, it looks like we're running into a little funny error here. Why is that? Oops, this is a bit of a funny error that you won't run into, but I will because I was still on a demo mode. But don't worry about that. I'm sure you won't run into that error, but if you do, the Nextcloud community is here to help you. So proud of this, man. It looks so good. It looks so nice and neat. All of the screenshots, all of your responses now grouped into nice pages for your documentation. That looks nice. Yeah, you get to talk about your transactions, running queries with the CLI, the limits of using DynamoDB when we ran into that error. So many moments in today's project. It was a pretty packed one. So let us now have a look at that LinkedIn post that you can use. So when you click on share on LinkedIn, now this opens up. Look at that. You can even make a post now on this project that you're doing today. You just have to click post, but all you have to do before you click post is click on that X here, so you now have space to upload your documentation. So what you'll do is you upload documentation, and I think it should be in your downloads folder. Let us just upload a PDF here. Shout out to Nikhil. I'm just uploading your documentation as an example today. And put in name as your document title, dash, query data with DynamoDB. Fantastic. And once that's done, you can now double click on that next work in your post, okay? And then make sure you're actually tagging us so we get notifications about it. We can shout up from the rooftops that you've done a next work project and hopefully bring more love to your post as well. All right, well, that is a wrap for today. You have completed the project, you have your documentation, you've posted it on LinkedIn. Please share your work in the community as well. We'd love to see it. And we hope you enjoy um, this learning process. We hope you've enjoyed trying something new. If you have any feedback on this project, if there's anything that could have been better, let us know in the comments. Don't hesitate. We're all about improving and continuous learning here. So that's a wrap for today. We'll see you in the next project. And happy learning. Bye.